Hi guys. You all know this. We started this quantum physics series. We done one hour video, and in that video we discussed about the what are the things going to be discussed in this entire series. It's like an index. This is a continuous to that one, and we'll start with facts about life. That's the first topic, I think. And in this mostly in this video we'll discuss like how the atom is existence is the first thing, and we what are the experiments discoveries happen about the atom. Then after we'll discuss about the photoelectric effect, and then one of the most important experiment, double slit experiment, that also we see after that. And we are not going to be more brief about that, we'll just touch over all that and we'll get some insight. And then yeah, after that we see Bells inequality is a small wala, and yeah, we'll discuss that also. Overall, let's give the overall thing about the basic stuff. Okay, let's start. First, we'll go with the autumn existence. If you see the autumn, you'll majorly get to know. Just two things you will get in your mind. First one is electron, and the another one is the proton. Let's see how the electron is going to was discovered. Electron was discovered by the J.J. Thomson, is one of the greatest scientists. Through the one of the experiment that he's done using cathode ray tube is a one this great guy and great person, sorry. And here you can see this experiment as a like a, as a one metal. So plate is there when connected to this one, and from here this electrons emitted and it's passed to here, and he placed some created some two magnets here, that side and this side. He connected with battery. By this way we can generate the magnetic field, and when the high voltage is applied, the electrons is passed from this way. Okay, when it is passed, you can see some deflection is happened. This slight deviation is happened to the direction of flow of electrons, and because some deviation is happened to the path, it because of something. And he discovered the electron. Initially he didn't name it as a electron, but finally people call it as electron. I don't know what's the name, but yeah, there's some name initially he named. This is about discovery of electron. Let's see how the proton, this nucleus, was discovered. uh, Nuclei was discovered by the Rutherford through the gold foil experiment. In this experiment we can see this entire the nuclear as a plate is there, as all the stuff is there. I am just taking this one atom and explaining the things. This one atom, this gamma particle is passing through this entire space. Only few are going to be reflecting and few are diverging this direction. And because of that he got to know that the most of the space in the atom is going to be empty. Only some part is going to be there, that is a positive charge inside, that called as nuclei. Similar to the Rutherford experiment, there's a few more experiments was happened after that, and by that we were discovered like quarks and some more elements in the related to the atoms. Okay, this is how the we were discover electrons and the protons. And now, yeah, now let's see the photoelectric effect. As a photoelectric effect is one more good important. We'll understand some basic stuff about the voltage and frequency relation and energy. Sorry. In this experiment, we consider two metals, is M1 and M2, and the M1, and we also connected some old meter here to detect the voltage difference. Initially we didn't find any voltage difference because they are in equilibrium state. And when we as sunlight is falling on that as a sun, okay, when sunlight is falling on that metal M1, this electron going to be released from this M1 is because of that there is a unequilibrium is generated between these circuit. It's like if you consider this whole as a circuit, this if you consider this whole as a one circuit, and because of electrons excited, there is some difference in the electron, and to maintain this equilibrium, the electrons from M2 are moving towards M1. Because of the difference in the electrons, we are going to be see the V naught. We'll call as generally. Here we will find the critical voltage at which the electrons will pass from the M2 to M1. By this we will get to know at what voltage this is going to be exciting. Okay, if you understand with classically, generally if you predict, let's predict what going to be how is the how it's going to be work. Like if if intensity of light is more, then we have more energy is going to be there because more intensity of light, and because of if it is more energy, then electrons get more energy, and because of that more gonna be released, excited. Because of that more voltage difference is gonna be developed. That means our prediction is like if the high intensity beam is gonna be generate high voltage difference, if the low intensity beam is gonna be generate low voltage difference. Oh, wow. uh, yeah, as our prediction is like more intensity beam is going to be get the more energy to the electrons, and we not going to be greater. Low intensity, this we not going to be less. uh, if you draw this plot for that, you will get the something like this. Here this yellow color is indicating this low intensity beam, and the red color is indicating the high intensity beam. But this is the way we predict, but actually the result is a bit different. That's why we are discussing the actually the voltage is independent of the intensity of beam. It is depends on the frequency of the light incident on that metal. If you plot the same thing to the with the rest now after see, if you got to know understand about this thing, you will see this one. This is the experiment results that we got, and this is what we predicted. And by this experiment we got to know this photo electric effect experiment. This V naught, as means with critical voltage, is independent of intensity of beam, but it depends on the frequency. Okay, it is independent of V naught is dependent on the frequency of light and independent of intensity beam. Let's see how this is gonna be. We know this equal to h nu, and we know kinetic energy plus potential energy is equal to the total energy. Total energy equal to h nu, and so kinetic energy plus potential energy is equal to h nu. Kinetic energy, this when this gonna be happen, this is equal to potential h nu minus potential energy, initial energy that has to move. Okay, if you draw this one, you can see that I'll get something like this. Okay. uh, on the y-axis we can call kinetic energy, and there's a frequency. There's a vc, critical voltage. At the critical voltage of the if the voltage is increasing, the frequency is increasing, the energy of the particle is going to be increasing. This is the minimum voltage that required to move the electrons. This is in this effect what we understand finally from the photoelectric effect. The voltage difference is developed because of the frequency of light, not intensity of the beam of light. That's the one finding we got from this one, and we represented that with this equation equal to h nu. And the next, let's see, uh, this is about the photoelectric effect. Now let's move into the double slit experiment. As very interesting, I love that one. uh, Double slit experiment is where we came into the quantum physics. uh, I got one slide from the Google. Yeah, there is the one. There's a beautiful image I found in the Google, and here you can see this light. When light is passed incident on this screen, there's a two holes are there, and because of these two holes, it form a inter wave-like structure, and you can see the interference pattern. So maxima here and the minimum, max, minimum. So you can see the more like this. And if you draw this one, you will get something. Okay, I'm trying. I think it. Oh, okay. Oh, sorry. It's minimum, max should become. Oh my god. Here is the minimum, max, minimum, max. Oh, oh, sorry. Here. Okay, no, fine. Oh well, yeah. I will get like this. You can see this one here. Yeah, what was the findings here? Let's see the what are the properties of the wave, and uh, the wave has the interference property, another property, and the wave is not localized, it's everywhere. But chunk, so particles have the localized, and it's not going to be so any interference effect, like if you take any ball, if you throw this, it's localized, it's not going to be like wave. But if see here, uh, when you insert a single particle, it is localizing, but when you insert a beam of light, it's going to be showing the interference effect. This is a weird thing. Because of this weird thing, this quantum physics is exist, and this coming to them, this is the basic idea to come to the quantum physics. Okay, yeah, as about the double slit experiment. Now let's see about the one more small topic is Bell's inequality. Here, so there's a one equation, and here is you can see this n of a conjugate of b plus n of b conjugate of c is greater than n of a c. Is represent the number of a not given b. Oh my god, something has happened. Okay, a not b, and the number of a not c, and b not c. And this is equation represent this the number of people are there a not category in the b, and the number of people in the category b not in c is always greater than the number of people category a not c. This is a most widely used equation in the classical physics, and this equation is not applicable in the quantum physics. Okay. Uh, you might be thinking crazily, why this guy is discussing which is not useful in the quantum physics. But yeah, it's most widely used in the classical physics, and quantum physics break this equation. That's the reason we are discussing now. Okay, we just given the overall thing about that one. Oh, this is all about this video. In the next video, we will start with the properties of the wave, and we'll see discuss some important properties of the wave function.